Grade 8s. I hope you guys had an amazing week and welcome to Monday Math. So for today we're going to start our new unit. I am going to do a little bit of review as usual, except it's just going to be a little bit of a quicker review because, to be honest, I've been looking at all the work you guys have been submitting over the weekend from our Friday math, and you guys are in tip-top shape, so I'm not really too worried about it. And I know you guys you're doing an amazing job. So for today's review, I'm going to give you another example of ways that a coordinate grid can be used in everyday life and how to figure out the distance between two different points if they're diagonal from each other. So I've used the examples of maps and a globe and things like that before. So for this example, I'm just going to use two different locations. So let's say I am figuring out the distance between Canada right here and Poland, which is about here if I had a world map. And actually, let's do this a little bit differently. Let's say Canada is over here. This is not necessarily accurate. Well, let's say I'm trying to find the distance. Let's say Canada, C for Canada, is at -2, +3, and Poland is at, so P for Poland is at, let's say 5 and let's say 7, just for the heck of it. So I want to figure out the distance between these 2 points. How do I do it? Well, I have to draw a right triangle, so I have to figure out these 2 lengths here in order to figure out this one. So in order to do so, I can count 1, 2, and then it's 5. So 1, 2, 3, 4, 5. That's 7 units across. And then how many units up is, so it's 3 and I go to 7. So from 3 I go to 7. 3, 4, 5, 6, 7. And that's 4 units. How do I figure it out? I use my my Pythagorean theorem. So a squared plus b squared equals c squared. So I do 4 squared plus 7 squared is equal to c squared. 4 squared is 16 plus 49 is equal to 65. And then I do the square root of 65, which is, forgot to pull up my calculator here. Square root of 65 is 8.06. So there's 8.06 units, or if I wanted to round it to 8.1, I can, units between Canada and Poland on this particular grid. All right. Now, today we are going into representing numbers in expanded form. Let me start this off by just using an example. So I have the number 1,209. So you would remember doing expanded form of a number probably, well, throughout elementary school you would have done it, is by using, remember when you used blocks, so you have like, this is your hundreds block, this is your tens, and these are your ones. So what we are doing is we're talking about how many thousands, how many hundreds, and how many tens and ones we have. So if I'm putting this into expanded form, I can represent it by 1,000 because I have 1,000. So 1,000 plus, my second digit is 2, which means 200. So 200 plus 0, I don't have to put 0 in there because there's no point, plus 1. Or sorry, plus 9, as in 9 ones. And this is the way I can do my one expanded form. If I add them all up together, 1,000 plus 200 plus 9 equals 1,209. I know this already. What we're talking about is doing numbers in expanded form using exponents. So remember, exponents are like that with like a 1 or 2, 10 to the power of 3, and so on. We're talking about how to represent that number in exponent form. How you would do so, I find the easiest way is to first put your number in expanded form like this. It makes it a little bit easier, in my opinion, to put it into notation, as in expanded form with exponents. So my first digit is 1,000. How can I represent 1,000 in a notation? Well, I know that 10 is a multiple of 1,000, as in I can multiply 10 so many times over and over and over again to get to 1,000. When we're using expanded form of numbers, you usually use 10 as your base. That's your go-to number. So I would use 10. How I would write 1,000 in notation would be 1 times 10 to the power of 3. Okay? The reason that 1 is there is because let's say I had the number 2,000. If I was doing 2,000 represented, it would be 2 times 10 to the power of 3. In this case, our example is 1,000. So I do 1 times 10 to the power of 3. I know this works because if I do 1 and then I do 10 to the power of 3, so if I use a calculator and do 10 times 10 times 10, or 10 to the power of 3 if you have a scientific calculator, most of you should have access to one because you all have your computers and devices. If you go on Google and just type in calculator, there's a second tab of that calculator that is a scientific one, if you don't know that already. But you have 1 times 10 to the power of 3, so 10 times 10 times 10 is 1,000. 1 times 1,000 equals 1,000. So that's how I would represent 1,000 in expanded notation. If I had the number 2,000, the only difference is what number would be this first digit. So 2,000 would be a 2, 3,000 would be a 3, 4,000 would be a 4, and so on. But it would this part here would always remain times 10 to the power of 3 for your thousands. Your thousands place is always going to be 10 times the power of 3. So I'm going to rewrite this. So 1 times 10 to the power of 3. That's our first part. That's our 1,000. Now let's deal with our 200. 200, so I'm going to add. I'm going to break this 200 down into expanded notation. 200 would be 2 times 10 squared, or 10 times the power of 2. Reason being is 2 times, what's 10 times 10? 100. 2 times 100 equals 200. So I do 1 times 10 to the power of 3 plus 2 times 10 to the power of 2. All right. Now our last part is plus 9. So I put my plus sign, but I don't just put plus 9. I put 1 times 9. And that's just the rules with expanded form. In this type of notation, you do it as 1 times your ones column. So 1 times 5, 1 times 2, and so on and so forth. All right, so that is one number represented in expanded form. I'm going to do another example. Let's just do this in a different color to make it easier. I'm going to do 1,349. First of all, I'll put it into this type of notation here. So I'll do 1,000 plus 300 plus 40 plus 9. Because if I add all those digits up together, I get 1,349. First of all, 1,000. So to do 1,000, I do 1 times 10 to the power of 3. Remember, with your powers or your exponents, the number that is your exponent is the number of zeros after the first digit. So you see how I have 10 to the power of 3? That 3 represents the 3 zeros that are here. It's just a little trick to remember in case you didn't know. So I have 1,000. I represent as 1 times 10 to the power of 3 plus 300. So remember how I did 200? I did 2 times 10 to the power of 2. I would do 3 because it's 300 times 10 to the power of 2 because 10 to the power of 2 is 100. 2 zeros, a 2 for the exponent. Times 100. If you would like, by the way, you can also put these in brackets just to separate them. So I know that this is my 1,000. This is my 300. Now I do my 40. To do a tens column, you do, first of all, your first digit is 4 times 10, but you still have to have an exponent here. You just do 10 to the power of 1. What that means is basically 10 by itself. It's really all it is when it has that 1 for the exponent, because all numbers, all single digit numbers have an exponent 1 right beside them. It's invisible. So I have 4 times 10 to the power of 1. I can put this in brackets because I know this means my 40. Because what this basically means when I wrote this out properly, it would be 4 times 10, which is 40. And then plus 1 times 9. And that would be my ones column. And I can just put that in brackets. And I know that this is my 9. So there we are. I'm going to do one more quick example, and you guys should be good to go. So what you're going to be doing today is you're going to be given a bunch of different numbers, and you're going to put it into expanded forms. You do not necessarily have to put those brackets there like I showed you. If you want to, go ahead and do them because I find it's nice. It just looks a little bit nicer because everything's kind of separated into different chunks. You do not necessarily have to do so though. So let's do the number 3,568. If I'm going to put this in expanded notation, my first digit is, so I'm going to do 3,000 plus 500 plus 60 plus 8. If I'm putting it into expanded notation, it'd be 3 times 10 to the power of 3. So this is my 3,000 plus 500, which is 5 times 10 to the power of 2. I know that this is my 500 plus 60, which is 6 times 10 to the power of 1. So that's 60, and plus 1 times 8. And that's my 8. All right, so you see how by putting them in different chunks like that, I can see 3,000 plus 500 plus 60 plus 8. Like this part right here, which creates my full number. Okay, so rule of thumb. If it has a 3, it's 1,000. You're in the thousands. If it's a 2, you're in the hundreds. A 1, you're in the tens. And an 8, 1 times a single number is a single digit, or ones column. All right, so that's all you're going to have to do today is basically you're going to be given a bunch of different numbers. You're going to put them into expanded notation. We're probably just going to be doing the thousands today. If you ever have a 10,000 though, so if you're in the tens of thousands, so let's say 10,567, The 10,000 you represent as 1 times 10 to the power of 4, because that 10,000 is a 1 with 4 zeros behind it. Okay, so today should only really be in the hundreds and thousands. We might do a little bit with the tens of thousands on Wednesday. But today is basically just a little bit of a refresher of exponents, a little bit of a refresher of expanded notation, and a shallow dive into our first lesson of this unit. Let me know if you have any questions whatsoever. I'm always around. I'm always available to answer emails, as many of you have noticed, at very odd times because I never sleep. And otherwise, I'll see you guys Wednesday, and I hope you have a fantastic couple days and enjoy the nice weather.